Okay, so from the video that you've seen, hopefully you can get a general idea of what is going on with two reactants when we mix them together. If we look up here at our definitions, now these are two of the four words that I wanted you to know for this chapter. Limiting reactant first is a substance that controls the quantity of a product that can form in a chemical reaction. In other words, it's the one that is going to be used up first. And then the one that's left over, we call that our excess reactant. So if I'm thinking about the exact demo that you just watched, the limiting reactant was ball A, and the excess reactant was ball B. Now, this is very practical for real-life chemistry because oftentimes you're going to have two reactants, and we know their starting amounts. Okay? Well, one of them's always going to run out first, and let's say you were in industry and you had one of these. Let's say this thing was very expensive. Let's say this was $1,000 a gram. Okay? And water, you know, is relatively cheap. Okay? Well, if I'm going to run a reaction like this and I'm making some kind of product that I'm selling for a lot of money, I want to make sure that I use up all of my PCl3. Because water is cheap, this one's expensive, and I don't want, when the reaction's over, I don't want to have any of this PCl3 left over. So it becomes a very useful thing in real life if you're going to decide on how much product of one thing you want to make. So the great news about all of this is that mathematically we're not doing anything different than what we've been doing. All we're going to do is look at the result of our calculations. So look at the steps I have right here, these three steps. All right, and you can see there the first thing, we're going to use the starting amount to find the amount of product produced. So I'm going to take these 225 grams and I'm going to figure out how many grams of HCl. And then I'm going to take this 125 grams of this one and I'm going to find out how many grams of HCl. Okay. Now, just for ease of use, let's just say that this made 10 grams. Let's see, the PCl3 made 10 grams, and with the water, we would make 25 grams. Okay. So I'm going to compare the amount of product produced. You can see right there that this one's smaller, this one's the bigger amount. Okay. And then here's the big overriding principle for all this. The reactant that produces the smallest amount, okay, that's our limiting reactant. So PCl3 produced that amount. So it is our limiting reactant. In the case of, if we're going to think about the little demo you just watched, the PCl3 would be A, the water would be B. All right? With water, we could still make more. Look how many grams of product we could make with our 125 grams of water. However, the important thing to note is this reaction is going to stop when we've made 10 grams of HCl because all 225 grams are used up. All right, so that is basically what we're doing. So let me show you the calculations with these two numbers that I had. There we go. Okay, so I've got that, and as you can see, this is the math that we do all the time, right? Moles, oops, I need my pen. That should be grams there. Got a little lazy. So I convert my grams to moles, I do a mole ratio, I find grams, all right? And then with that many grams of PCl3, I would make 179 grams of HCl. With 125 grams of water, again, find some moles, do a mole ratio, find some grams. I would make 253 grams of HCl. Okay, so back to our notes. Look at this. Since PCl3 makes the least amount of product, it's the limiting reactant. Okay, and then water is the reactant that's in excess. All right. Now, what I'd like to do is just take a moment and find out how many grams of H3PO4 was made. Okay, pause the video. Do that. Okay, hopefully you did it. Now, you might think that I've got to do the same exact process that we did up here. Okay? But what happens is we've already established that PCl3 is the limiting reactant. So, all I need to do is go 225 grams. 1 mole is 137 0.32 grams. And then my mole ratio is it's 1 mole of PCl3 to 1 mole of H3PO3. All right, then 1 mole of H3PO3 happens to weigh 82 grams. And that's going to equal 134. Hopefully you got that, right? Now the last thing that I want to note is look at our two starting amounts here. Notice that PCl is 225 grams, H2O is 125 grams. Now we know that PCl3 is the limiting reactant, okay? We know that. If you look at the starting amounts, you will notice you can't determine from how many grams you start with who's going to run out first. Okay? There's two issues. One, we're talking about weights, and we have to deal with the fact that we have molecules and compounds that have certain weights per mole. And then the other thing is we have this ratio to deal with, this 3-to-1 ratio. All right? And so you can't simply look at a reaction and go, oh, the smallest number of grams will run out first, or the biggest number of grams. You have to work this out. And like I said to the class, your book, the way that your book does it is have you go all the way to the end to get the grams of product. And the nice thing about that is often you'll get two questions. You'll get one, who is the limiting? And then two, how much? Oops. So unlike the way I learned it in college, unlike the way we do it in AP, this kind of saves you a little bit of time. All right? So let's move on to another problem. Okay, here's a true-false question. When 42 grams of MgI react with 42 grams of KOH, MgI is the limiting reactant. Okay, that's a true-false question. And then what I really want you to do is figure out how many grams of Ki are made from the limiting reactant. So to do this problem, we have to work it out just like before. Okay, so I'm going to start over here. I've got 42 grams of MgI, 2. Okay, I'm going to go grams of this, 2 grams of Ki. Right, so that happens to weigh 278.11 grams per 1 mole. The ratio for 1 mole of MgI2 equals 2 moles of Ki. And again, just for those of you who aren't following too well, there's a 1 understood there, and here's my 2. Okay, so that's where I'm getting my 1-to-2 ratio. Now I'm going to find grams. 1 mole of Ki weighs roughly 166 grams, and that gives me 50.1 grams. That's how many grams will be produced from that many grams of MgI2. All right. Well, we got to still do the KOH. So we've got 42 grams. Oops. Let me try that again. We've got 42 grams of potassium hydroxide. Again, grams of grams. The beauty of this is it's the same format every time. All right. 56.106 grams. Okay. The mole ratio is 2 moles of KOH to 2 moles Ki. All right. 1 mole of Ki happens to weigh 166 grams. And with that much potassium hydroxide, I would make 124 grams. So who's the limiting reactant? Well, the MgI. Why is it the limiting reactant? Because it made the smallest amount of grams. Okay, so it's understood that KOH is in excess. And again, all we're doing is looking for which one of these two reactants would make the smallest amount of product. All right. All right, so let's try another one. So if we look at this question, by the way, Is MgI the limiting reactant? The answer would be true. All right. On to another one. All right. So here's another problem. I want you to pause the video. It's a multiple choice question up here because we're using the clickers. But I want you to figure this out. And then I want you to also figure out how many grams of H3PO4 will be produced. Okay? Pause the video. Take a moment to do it. Okay, you may have noticed that I gave you moles. Not a problem, right? I actually saved you a step. So I'm going to go ahead and take my 3.00 moles of PCl3. Okay, now when we have moles, what's our first step always? Yep, mole ratio. So 1 mole of PCl3 for every 1 mole of H3PO4. Okay? And the reason I'm finding grams of H3PO4 is because of this last question right here. Okay? It doesn't matter. I could be going to grams of HCl, but this is going to save me a step. So 1 mole of that, right, happens to weigh 82 grams. Okay? And that would equal 240. Oh, that's terrible. Let me write that out there. That would equal 246 grams. Okay. Well, let's go ahead and do that with the next one. So that's how many grams 3 moles would make. Well, let's see how many grams 4.5 moles of water would make. Okay. You know the process. Again, we saved a step. So the mole ratio of water to H3O to phosphorus acid is 3 moles of H2O to 1 mole of H3PO4. Then again, finding grams gives us 82.00 grams. And with that many moles of water, I would make 123 grams of phosphorus acid. Well, I keep writing 4 there. You're probably screaming at the screen the whole time. Sorry about that if I confused you. Okay? So there we go. So the question I have for you is, which reactant is limiting? Hopefully you'll go, well, the water is limiting. Okay? Water is my limiting reactant because it made the smallest amount of product. Right? Hopefully you're getting a feel for it. I've got one more. Okay, so here's a question. I want you to pause the video right now and try this problem all by yourself and see if you get the right answer. All right. So my question to you is, how many grams of manganese are produced? Well, if you got 2.27 grams, pat yourself on the back. All right? So this is how we do it, just in case you didn't get that answer. So I'm going to take my starting amount, 3.59 grams of Mn. Oops, a little sloppy there. Sloppier than usual. MnO2, right? And again, same process. I'm going to convert my grams to moles. 86.938 grams is 1 mole. 3 moles. 3 moles. Okay. Here, let me slow down to 3 moles of Mn. Okay. 1 mole of Mn happens to weigh 54.938 grams, and that equals 2.27 grams. Okay. Now again, we got to do the other one just to make sure. So I've got 12.6 grams of aluminum. Okay, 1 mole of aluminum happens to weigh 26.982 grams. The mole ratio between aluminum and manganese is 4 moles of aluminum to 3 moles of Mn. And again, I'm just getting this from the coefficients of the reaction. 1 mole of Mn is 54.938 grams. Okay, and when I work that out, I get 19.24 grams. So again, if you were asked the question, who runs out first, you would go, well, the MnO2 runs out first. The MnO2 is the limiting reactant. All right, and then as this question asks, how much was made? Well, the answer is right there, 2.27 grams. Okay, hopefully this makes sense. Again, if it doesn't, like always, come see me. We can do practice problems and get this all worked out.